All right, it's going.
Please continue.
Okay, so, yeah, there are a total of 3 motors. The program works by accepting user input for the number of steps a user would like each motor to take. After entering the steps for each motor, the motors then start spinning at the same time. After all motors are done spinning, the user is prompted for input again. So here are a list of the main tools we used. I'm sure you're all familiar with these. We used the Arduino IDE, the serial port, real-time operating system, semaphores, stepper motors, and we had to use an external power supply. Here are our functional requirements. If you guys would like to take a look at them for some time, I can leave it open. If not, I can just go to the next slide.
Just forward, you just go
Okay.
forward, yeah.
And here is a flow chart for our program. There are 2 main phases in our program: accepting user input and spinning the motors. Every motor has a semaphore that is required to spin the motor, and all motor semaphores are required to collect user input. The program starts by the take input task, taking all of the semaphores, and then saving user input for each motor. After user input is successfully saved, the semaphores are then released. After the semaphores are released, each motor will take their semaphore and initiate spinning. Once they are done spinning, they release the semaphore and they are collected again by the take input task. Not all motors release semaphores at the same time. If a motor is done spinning before another motor, it will release the semaphore. But the take input task will not run until it has collected all of the semaphores. This means that it will not accept user input while any motor is spinning. Here is our setup. The simple things required for the setup are that a real-time operating system needs to be installed and the serial port needs to be enabled. Something that needs to be altered with the serial port is the ending selection. I didn't know about this, but we had to do research on it. The possible options are no line, new line, carriage return, and both new line and carriage return. Depending on the option selected, extra characters are appended to the input after clicking enter. The no line ending option needs to be selected in order for the program to work correctly. Other options will not work correctly as they will send extra characters that will then be read by the program, preventing it from reading the user input. We originally had the default option selected being a new line, but this would cause a 0 to always be entered for one of our motors because the program would read the new line passed down as a 0 entered. The final thing to note for our setup is that the motors require an external power supply. Originally, we tried running the motors only on the Arduino board's power, but it was not sufficient to power them.
Hello everyone, I'm John and I will be starting off with functions. Our project consists of 4 main component functions: read number, spin X, spin Y, and spin Z. The read number function reads a number from the serial port and returns it as an integer. It first declares an integer variable input steps to hold the value entered by the user. After this, a while loop is entered to check if there is any available data to read from the serial port using serial.available. If there is data available, the function reads an integer value using serial parseInt and assigns it to the input steps variable. It then prints the value of input steps to the serial port. Using the serial.print and finally returns the value of input steps to the calling function. Spin X, spin Y, and spin Z all work in a very similar way but on different motors. So I'll take spin X for example. Spin X starts by making sure that the input it is using is not 0. If it's not, then the function takes its specific counting semaphore, waiting for the semaphore to become available before executing the rest of its function. After this function prints the value of the numeric input, identifying it as X, and prints out that X is in fact spinning, immediately followed by setting the motor speed as well as moving the motor based on that value of X. The vtask delay function is placed at the end of each of these 3 tasks, spin X, spin Y, spin Z, in order to provide a small delay between each iteration of their while loops. This delay is necessary to prevent tasks from hogging the processor and consuming all available resources. vtask delay instructs FreeRTOS to put the task in a block state for a specified number of ticks, after which the task is automatically moved to the ready state and ready to execute again. Next, I'm going to be going into the hardware requirements. For the hardware requirements, we have, of course, the Arduino microcontroller. We have 3 stepper motors, and as Jaime was pointing out earlier, we needed an external power supply to be sufficient to run all 3 of these motors. The other hardware that we have to put together this project was 3 pen barrels, as well as other lightweight material to make up different arm segments, and this basically consisted of adhesive material to hold the pen barrels onto the motors. Next slide, please. Okay, and now I'll be talking about limitations. Some of the limitations we had were we had small stepper motors that were not able to carry too much weight. As a result, we were limited to basically pen barrels to actually run the arm. Also, the wiring of the stepper motor limited the range of spins for each of the arm segments. The arm segments that were controlled by the Z motor, as a result, are able to hit the base. The user also does not have a way to change or alter the speed, and the user has no safeguard against stopping the process of spinning the motors in case too much rotation is entered. Next slide, please. So for our future works, we wanted to actually have the opportunity to maybe use some stronger motors. We use also longer wires to prevent wires tangling, and also to prevent that Z motor from the base hitting it with longer and stronger arm segments. We also wanted to be able to, we didn't get to provide a home feature for each motor to return to its starting points. This would be an interesting control feature, as it would allow the user to enter as many arm movements as they like, but to be able to always to return to that origin. And we would also like to allow the user to change motor speeds. One concern I wanted to add with the changing the motor speeds is being able to actually add more. It may be necessary to add more power, because running all 3 motor speeds on more powerful motors at a time will require a varying amount of power. To our last future work is to add a claw to the end of the arms that would be able to grab items. This would go a far way to actually realistically simulate a realistic robotic arm. Next slide. Now we're going to get into the demo.
So
Okay, you can turn on the lights
yeah,
and.
could we show the code first, because the demo
No,
we're
code
gonna do
we'll
over
see
there.
last.
Oh, later?
Let's see the
Okay.
demo now.
Okay.
Can you please turn on the lights?